Hello, hello. Okay, we are live again. All right, guys. Welcome back to the stream. Let me pop out the chat so that I can see it here. Okay, let me just start a poll. First of all, welcome again, guys. If you are new on the stream, make sure you like the stream. And if you don't like it, tell me what you don't like. Okay? The poll is running on your screen. Make sure you opt for the polls. And if you don't want to engage in live chat, that's okay. You can disable the live chat option from from your options of the screen. And that way you can have a good view of this live in your mobile devices. So we'll wait for a few people. And if you are here, I would like you to just say hi on the chat or off for the poll or like the stream, and we will start this thing. So today in afternoon we had a small, for an hour or so, like the stream in which we learned about our exercise that we are doing, that is multi-threaded word counter. We implemented a basic minimal thing of it, where we have to figure out the occurrence of each word, how many times it occurs, right? So yeah, this is what we implemented. And now we need to implement a thread safe version of it. So we are going to do that. But I want you to opt for the polls right in your screen. If you don't like the stream, let me know what you don't like. And if you like the stream, make sure you show it by hit that thumb. Okay, so let's start this thing. I hope I am audible, like well. Let's put this thing onto the top again. Yeah, I think this is good. All right, so let's start. Yeah, so we implemented this thing, a basic hash map and all. Now we need to implement the thread safe version for it, right? And we learned that if you want to implement a thread safe version, we have to implement threads, right? We have to spawn the threads, and we learned few things about it that we have taken a note of, right? These are the notes that we are going to use arc and mutex. It is pretty common pattern that we can see if you want to implement thread implementation or share the data in between multiple threads. So we have to use this arc and mutex implementation. We'll use arc and mutex. Arc is a thread safe version on RC, that is reference counted. These are the primitives provided by Rust, arc and mutex. A mutex is basically a mutual exclusion. It is provided by Rust, and it it helps threads, kind of making the element that the threads are accessing thread safe by providing a lock method. So thread has to acquire lock so that other threads cannot access it simultaneously, and to prevent the data race. Okay, How to make data structures or any type thread safe? We have to wrap them in arc and mutex. This is the pretty common signature that you can see. Inside this are type, it could be anything, and it is wrapped by mutex so that thread can access it. And we have to use atomic reference counting as well. So basically arc is used to share the ownership between multiple threads, right? We can clone it. So basically it doesn't do any deep copy. It just simply increment the reference count of that type. All right. One more thing that is mandatory is once all the thread finishes their job, so we need to call join method on each of the handle of the thread. So this is mandatory, otherwise the program will simply exit. Okay, so let's say if we have thread 1 T1 and thread 2 T2, and each of their respective handler is H1 and H2. So once they all finish their task, we need to call join on each of the threads, right? So we have to call h1 dot join and h2 dot join. Okay, otherwise the program exits after the result. And yeah, the dot join basically it returns a result, and result has two values, okay and error. Okay, so yeah, let's go ahead and implement the thread safe version of this thing. All right, and how to do that? So this is our data structure hash map that we are using to count the reference. But before that, let me just show you what it gives to us, right? I'll just do cargo run. So you can see I can have the count over here as well. The is 3 times, lazy 1, brown 1. And what is the string that we provided? The string that we provided is this: the quick brown fox, the lazy dog, the, right? So this is our sentence. Basically we have to read a complete file over here, a very big file. Then only you can see the difference the thread makes, right? So in order to check, like see the noticeable difference which thread makes, you have to have very large file. Otherwise, for the shorter sentences and files, the single synchronous thing is pretty good. So here what we need to do, we have to count the times each word occurs, right? It's a basic interview question as well. So you can see the first word, the is in this sentence is appearing 3 times. The first one over here, the second one after the fox, and third one after the dog. So you can see the result, the is coming like 3 times, and all other things, all other words are there 1 times. And this is what we have to show, right? Like this, right? Dog 1, lazy 1, fox 1, brown 1, the is appearing 3 times. But now we have to make it thread safe. So let's do this. Again, we know that if we want to make this thing thread safe, we need to wrap this thing around arc and mutex. Which books or PDF you are referring? I am referring the official Rust book that is there. You can just say type like the Rust programming like this. Over here you can get the that book, the address, like read the book. If you want, I can just read the book. So there you go, this is the book. If you want, I can just paste it over here. So the comment that you are seeing is the reference of Rust book. It has all the things you need to like get started with Rust. Other than that, you can also side by side do all the things that I have written it over the PDF over here. So the Rust official book is must. It's the primary spine. You need to understand ownership, like borrowing, lifetimes, traits and generics. Traits and generics, we covered it on the last exercise that we had. Ownership and borrowing, we are just continuously observing in each of the exercise. Rustling, on the other hand, you can do it parallelly. What Rustling does is, whatever topic you read from the Rust book, you have to have the hands-on exercises along with that. So you can do that. There is also a thing called 100 exercises to learn Rust. These are project-based course you can do, right? You can also search for comprehensive Rust on Google, like Tokyo official tutorial. Okay. I also have created a video over this where you can build a basic Redis, from scratch using Rust. So you can check out that video as well. Async programming in Rust, like official async books, and that really help us to think behind the future spinning and executors and all. I have also created a video about pin and unpin in Rust. You can do that. And most importantly, on YouTube, you can just go and check out this man, John Jenkset. It has a Crust of Rust series on YouTube that is pretty much kind of between intermediate and advanced level of programmers. So you can go there. It really, deep dives on the things. Okay, so yeah, here we are. I hope you get it. And yeah, let's make this thing thread safe. Okay, and how to make it thread safe? We can always wrap this thing into arc. So we have to get this, import this mutex, and inside this we can have our hash map. Right now that we have initiated this thing, so we'll have to do something over here as well on the new function, right? So we can do arc new, right? Mutex new, and inside this we have to paste our hash map. So you can initiate the hash map over on the new. Now we have some issue over here. I cannot access the store.entry because it's now wrapped in arc and mutex, right? So what we need to do, like I said, if you go through this thing, so what we need to do is, we have used arc and mutex. Now we need to spawn threads, and spawning a thread will need to it takes a closure, and that closure has to be moved. Inside this we have to, again, once the all thread like kind of process their work, we have to call join. Okay, so how to do that? So first of all, let's so we already have the splitted string, right? So first of all, let's create the handles for the matrix. So vector, right, for the threads, sorry. So I'll say let handle equals vector, right? Let's do this thing, initiate an empty vector. This will be our macro rules. All right, so we'll push all our thread handles in it. Okay, now instead of doing this we can create we can spawn the threads over here, right? Now the question here is how to know how many threads we have to initiate, right? So let's go and check the threads documentation over here, or maybe we can just type it over here, and how to check the threads in Rust, how to check the available, because So there must, okay, this is the thing, available parallelism, which has been available since Rust. Okay, so it's newly, I think it has been added later. To check the number of available logical processor for the thread pool sizing in Rust, use the standard library function available parallelism. Okay, so we are going to use it. We can have it like count, and once we have that count, we can initiate, we can run a loop around this thing up to this count, and we can generate the threads according to this thing, right? Because there will be only one thread that will take the log, so it won't be any like heavy on the CPU. I hope so. Determine the number of cores using the num CPUs, Rayon thread pool, number of CPUs that we available parallelism. Yeah, I think we can have a little bit of deep dive on that. But surely we will use this function because I can get the count over here, right? I can say thread dot available parallelism dot unwrap because it will return a result. And once if it's an okay thing, then I can use get, then I'll have the count over here. I can use that count this. And if we really want to divide the, the very large string using the threads, so we need to also like create the chunks as well. Chunks in the sense, let's say we have a very large file. So if we have a very large file, we cannot like kind of run a loop on the threads and assign them. We can assign different chunks to each of the thread. So we can have the chunk size as well. But let's see, let's not go that deep. Let's first create the very minimal thing. Okay, with arc and mutex. So we'll surely use this function available parallelism, but let's go a little bit deep on it. Return the estimate of default amount of parallelism a program should use. Okay, parallelism is a resource. A given machine provides a certain, you're able to see that. Yeah. We have 2 votes, that is good, and 2 likes. You know what, maybe I can just share the stream URL onto some platform so that I can have some people joining. Maybe I can just copy it. So I'm just posting the URL for stream in Twitter and LinkedIn so that we can have some people joining. Okay. Host environments such as VMs or container orchestrator may want to restrict the amount of parallelism. The purpose of this API is to provide an easy, portable way to query the default amount of to be used among these regions. Okay. It may account the 54 So I can use this, right? Available parallelism. This way I can propagate the error over here. All right. Okay, so yeah, so we have created these handles, right? So now let's do, we can say let um, maybe, yeah, I can find. We could have something like this, right? It's a basic counter over here, and handle is the vector that we have created as well, and we can just update this thing over here, right? Counter clone dot lock, because inside this clone we have the mutex and we can like dereference it and just add one to it. So this is somehow we have to do something like this. So let's do that. Maybe we can say 7, right? And over here what we can do, over here we can just say let handle, why handle, because thread dot thread dot spawn, it returns a join handle, right? And this thing, it takes a closure, right? Over this closure we have to implement few things. Okay, as I already told, we need to kind of, each thread has to take the ownership, so we'll just say move over here, and each of like this, because now it needs to take the ownership, we have to take the clone of the store, right? So I'll say let clone store is equal to, I'll say self, not self, I'll say arc dot maybe self dot store dot clone. We can say something like that, right? This is the cloned arc, right? So the counter clone is this. Basically, it cloned the counter. So probably we should do those as well. Clone, right? And over here, what it takes a self of type and self, and you can say self dot store, right? We have a clone store, and once we have a clone store, what we can do, we can say let count equals clone store dot lock. It will return a mutex guard over here, right? Because clone is from the mutex, so it will return a mutex clone, mutex guard. That guard will be automatically dropped after this scope is over. So now it returns a result. So either I can use an unwrap or propagate the error back, because this is going to propagate the error from here, right? So I can do that, this, right? I have the lock over here. Now I can just dereference the, okay, so this count basically has the store, right? Maybe I can just see what the count is. I can just, remove this thing for now. The operator can only be used. Okay, so I think I have to, for now, let's do this. Doesn't implement display. Okay, type annotation needed for the vector. Let's remove this as well for now. Unused handle, unused array. So it's a warning. We don't really care about the warnings right now. Let's see how it goes. We need to see what the count has. Basically, if I do, so basically I have the lock right now. Okay, the mutex guard is over here. This thread over here, each of the thread that I spawn from here will have the lock of this thing, so that no other thread can, basically change this thing. Let's see. Poison fall. Okay, so I have the mutex guard now. Okay, I have the mutex guard. Does it have super? Okay, now that I have lock, what I can do over here is uh, blah blah. So basically I'll have the store or map over here, right? So what I can do, I can just, instead of this thing, I can just use a match over here, right? And because it's what is returns, it returns a result. So if it does, I'll just do map, and for the error, I'll have to turn the error from here, right? Arm says incompatible type. Why it says incompatible type? Mutex guard. Yes. So basically returns a mutex guard and poison error. I already have the boxed in error, right? So maybe instead of doing this unwrap, it is very, panic. Recover from poisoning. Okay, so poisoned into error I can do, right? Poisoned into error. Into inner. What the heck is this? So I have the poisoned error here. So a dot into error. Super. Okay, so the instead of using an unwrap, we did a kind of match, like kind of do a match statement over here, and I have the map right now. So if I do print len, okay, maybe I can say let count equals map dot entry. I can say item. Wait a minute. Wait a minute. I cannot run a loop inside it, right? For the very big string. What we can do here? Any idea, people? Not even I can use. This is the wrong thing, I think. Here it's just incrementing the counter, so there is no issue of this thing, right? It just do this, it is automatically released, handle dot push, and blah blah blah. Maybe I can just say yep. Yep, Adi. How are you, man? Typing has been argument is a standard Rust pattern for reading threads and mutable state. Okay. blah blah. That's what we are doing right now. Map guard, I have it. Insert. Access the map from the main thread. What the heck is this? Map guard dot key map. Okay, this is the main thread. What if I want to spawn multiple threads? So basically the handle over here is this. Using arithmetic result in the cross grain locking means the entire map is locked. Yes, I know it, but this is the requirement. I know, but the exercise specifically want us to feel the pain so that we can embrace the async runtime environment. Alternative for high concurrency, for a read heavy workload, consider using RW lock instead of mutex to allow multiple simultaneous reader. For better write performance and fine-grained locking, consider specialized libraries like DashMap. Okay, I know that, but we need to use Arc and Mutex, man. So what if I spawn multiple threads? Let's see. How many people are watching? 4 people. 5 votes we have. When you spawn multiple threads sharing and the code remains safe but often become inefficient due to log contention. Okay. Each thread clones the arc to gain shared ownership and then calls the log to access the map. Okay. Show me the code. Yes, we did that arc clone and we pass the map. Okay. We have a handle that I can push and later on do this and data dot insert. So basically data insert the key and value, right? But the issue is this, I need to check for the I need to count the words as well in it, right? So what we can do over here, guys, we have a specific problem. We have a specific problem that we can spawn threads, but the issue is how each thread is going to work and help us to count the words. Any idea? Any suggestions? This is where I had it, right? So The count you can wrap map to share it, clone the arc for each. Yeah. Yeah, that's. I'm just curious to know. Okay, it says words that I already have for. Oh man, shit. Why I'm doing this? I can just like for each thing I can do that, right? So yeah, I can do this. I totally forgot. So we have that splitted string, right? So I can say for item in maybe substring, I can call it, but let's call it item in splitted splitted string. Here I have each item. Brother, where are you from? Crazy boy Ravi, look at me. What do you think? I just remember a meme. That guy, I think he's some, from America or something. So it says, so someone from the India asks, "Where are you from?" So that guy says, "I'm from your mother." I don't know if you have heard them. Seem to be from around Delhi. Yes. Okay. I have the item. So what I need to do is for each of the item I can, right? So I'll say let handle equals thread spawn, right? It takes this thing, right? So I have to move it. And how are you, buddy? Crazy boy Ravi, what's your name? Is it Ravi? So from each of this thing, probably we can just we can clone it, right? And inside this I can just do self dot store. Yes, brother Ravi. Okay, Ravi, where are you from? Are you from Delhi or somewhere else? How are you finding the stream? Is it good? Is it boring? How is it? Cloned arc. Okay, so this way I can have this thing and the word as well. So probably I can just say let map equals let map equals cloned, cloned arc dot lock. Should I use lock or get lock? Do we have as such do we have get lock and mutex and rest? No, Rust music does not have get lock, so I think lock is the one, right? The querying lock is lock. Okay. Haryana. Nice, nice. Yeah, power. Uh, cloned arc. दूध दही का खाना, हाँ? cloned arc dot lock. So this returns a result, right? So I have to use a match over here, and once I use match, I can have the map over here, which I can return. And on the error e, this error would be a poisoned error that we just did, right, into inner. Okay, so the map is never used. We are going to use it. Okay, map. So this map has basically our wrapped store hash map. So I can say let count is equal to map dot entry, and I can have the key over here. So I'll say item dot to string, right? And this entry, it returns, we need to go on the signature, it returns the, I think it's a returns a value, right? Insert. So why I'm doing this, I hope you know. Default value is 0, right? I hope you know why I'm doing this. Returns a mutable value, right? The count. So we will dereference it, count plus equals 1, and after this the thread, the mutex cards dropped, the thread is over here, and after all this thing like running on through the string, what we can do is we basically forgot to add the handle, right? So after this thread is done, what we are going to do, uh, we have to create an handle as well. So let HANDLE handle store. And why I'm doing this, crazy brother, everything seems boring in the beginning, so start learning something gradually, you start enjoying it for a while, but everything is boring again. Okay, yeah, I understand. No problem. Yeah, it's okay. uh Totally get it. So type annotation needed. This has to be mutable because we are going to mutate it. Yeah, so are you into tech? I mean, Ravi, are you working somewhere? Are you into tech? Uh, so this, after this thing, after this handle thread handle do this, what we are going to do, we will just push it over here, right? So I'll say handle store dot push. I'll just handle it, right? Now the text over here is cannot borrow map. Cannot borrow map. A few things. Let's do cargo build to see what's the error. Ah, too much of an error we have. Cannot borrow as mutable. Cannot borrow as mutable. I have to make it mutable, so that's the issue solved. Borrowed value does not live long enough. Why? Because this has been inside the closure. Started with friendly runners. So amazing, man. What's your tech stack? Is it JavaScript? Are you into MERN or something? JSTS, noise, brother, noise. My tech stack is mostly JSNTS, but somehow I managed to, do the backend part in Rust. The front end I do still in, JavaScript, TypeScript. So yeah, best of the both worlds. So yeah, JSTS is good. Noise. So you're working somewhere, right? Okay, so first of all, we need to, make it mutable because we are mutating this thing, right? Secondly, it says text doesn't live long enough. Why is that? We are not using text anywhere, right? We are just kind of doing this thing. Working on by, yes, I'm also learning Rust. Crazy. Good, 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 good. Noise, man, noise. Full-time work from home. Arre wah. Great. So is it a remote job or like hybrid kind of thing? Are they paying well? Argument requires that text is borrowed over here. Okay, so splitted string does not live long enough. No, 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 don't do this. Uh, so as you are watching this, make sure you leave a like on this stream and let me know if something is not working out. Okay, so it says text is no. Let's see. Borrowed value does not live long enough, but why? Text declared here. Argument requires that text is borrowed for static. Requirement value text outline static includes fully remote, not moderate as well. The more we give, the less it takes. Hmm. Yep. Yeah. That's good, man. So is it like a US based company or well, I hope so. It's a US based thing. If I creates a temporary value which is free while still in use. What is this, man? Do we have to? No, mixing India and Singapore. Noise. Anything is good, man. Anything is good. So a remote, fully remote is like all the way very good. It says text drop here while still borrowed. Okay. Self.store, right? I'm just passing it over here and dropped here. Borrowed value does not live long enough. Let's do the today. Returned owned data. If returning a reference to a local variable, clone or own the value. If storing borrowed, return the hash number. Clone the data to create a owned version. For example, using toString for this or dot clone for the types. Scoped thread over arc. When spawning threads require closure to be static owning its data. Use arc to share the ownership of data, and that's what we did, right? Do we need to wrap this thing as well? The main issue here is why the heck is this thing throwing an error? Or handle in handle store, I can say, you know what, I can have to handle this, and I can just say handle dot shown over here. Now the join returns a result, right? Probably we can just, gracefully handle the error here as well. So if it's an okay, I'm not going to do anything, right? Whether what kind of ext is that tracks the groom's lifetime? Oh, it's not ext, it's text. So this text, it's a variable name. So yeah, I'll get back to you. Just give me some time. If it's an error, I want it to be returned, right? Messaging okay. What should I do this? Found box didn't expected this. VS Code extension who give, okay, okay. VS Code extension who give hint like here we define let const here, borrowing drop, etc. Yeah. So I don't know about VS Code. It's nvim. So it's a default like LSP that is working over here. So yeah. And if you want like kind of this configuration that I have, I'm using kickstart nvim. You can get it on like GitHub. Just search out for kickstart nvim and set up your nvim and just enjoy. Otherwise, I think the VS Code extension that you are looking for, it could be anything, right? I mean, if you like install it, it will do. Install the Rust analyzer, maybe that will help. Box bin, I mean, maybe we can just, I guess nothing here, just print. Is whether uninstalled by default Linux. I have never opened till day. My bad. Yeah. So okay, once we do this, I think we are done. Why? Because we spawned threads, and once the thread processes, we just called join on it. So that will do. You know. But okay, yeah, yeah, that is done. Just do this. Text drop here while still borrowed. Is it? But we are using, where are we using text? I mean, text is, the job is done, right? Even if I clone it, borrowed variable. Okay. Mm-hmm. What does this return? Mm-hmm. I have the splitted string. Cannot borrow it, right? Clone arc dot lock. It's mutable. What does it shows? It is giving me a mutex guard and a hash map. Mutex guard on the hash map. Are we missing something? We take the lock and like work on it, right? However, right now we are sending the ownership of the text to read text, so that we do not need to take a copy. According to me, right now we are sending the ownership of the text, so we do not need to take a copy. Okay, dot unwrap. Log the mutex inside owned string, so we need to have the owned string and drop the. Okay, what? What is this? Handling reference in lifetime, you cannot return references to return them directly because the mutex guard the log handle is temporary. Map dot get mute. Get mute. Now this is the thing, right? Get mute. So let's get mute. What is this, man? What it needs? ID. And it's an if let statement over here, right? If there is some value, then I can simply mutate it. But this doesn't make sense here because I need to check for the counts, right? Hmm. No. Yeah, so what you are saying, Ravi, is right now we are sending the ownership of the text to read text. Ownership of text to read text, so that we do not need to take a copy. Argument require that text is borrowed for static. It says argument. So you see, I'm just kind of doing this thing because for a mobile view, you guys cannot see the entire thing. So this way, my all the info is being, hidden behind. It's not wrapped basically. Probably if I press enter over here, I can. Nothing. So it also like says some info about here as well. You can see the question mark, like this thing over here. Arguments require that text is borrowed for static. So there is issue is on this line only, where I'm spawning and moving the items. Yeah, the complete page is not visible because for the mobile view, this so that is why I'm doing like cargo build each time so that I can see some error over here, right, like this. Cloned arc. I cannot do cloned arc inside this thing, right? Because I have to pass in the self.store cloned arc. Okay, so for each of the item I get the cloned arc. I take the lock, and that lock basically do the complete thing. All right, we have 17% people who says the stream is not good. So guys, if you can just tell me what's wrong. Okay, I can see we have 2 likes. So going good. What can be done here? It says text has to be something, there is some issue with the lifetime because the error is clearly says that this thing is not real. So this is my main, by the way. I'm passing in the string, the owned version, right? We have some suggestions here, right? Sing and concurrency when using a single or toString value dot toString. Lock is dropped here before any await. Does not need to be mutable. Hmm. I think this time we need to let's see what do we get. Uh, we already did item dot toString. Drop scope threads. The primary issue is incorrect error handling. Oh my god. And unnecessary data cloning. Incorrect poison error handling. If you match in your match block, you use into when the lock is poisoned. Yes, okay. On this part, it says we are just it's a poisoned thing, right? The error is the poison log. So first of all, uh, the issue is over here. But again, it's a very improvement, right? Consume the error and return the mutex guard. But if you do without handling the fact that the data might be corrupted, you silently ignore the panic that caused the poisoning. While technically valid to recover the guard, but is to either propagate the error or explicitly handle the recovery logic. If any of the thread panics, your current logic continues as if nothing happened. Okay, so basically we have to show panic over here, right? So we'll panic. What's that? We'll panic. Uh, yeah, let's panic. Let's panic over here. I think it's a good approach, right? It says that we handled this error and we did nothing basically, right? So if we do nothing, then if there is any error or the data is poisoned, then the thread will keep on going. So we have to like panic here, right? So it's a good thing. Logical flaws, excessive threading overhead. You are spawning new thread for every single word. There, yes, 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 we need that. Yes, we need that. If text has 1000 word, yes, yes, we need that. Thread creation is expensive. This will be significantly slower than, yes, yes, we know. We even know that for disk operation like this, a simpler thing would be quite good, but the exercise says so, just so that we know the trade-off. You call item inside the thread since item and string the driver. Now this is the thing. Utilize your parallel code, negating any benefit of threading while adding massive overhead. Thread creation is expensive. This will significantly slower than a simple sequential loop for most input. Through passing string to thread is common. The bigger issue is the contention. All threads are fighting for the same lock. This serialize your parallel code. Okay. Left time and move issue. The code generally compiles if is an arc mutex string i32 and item is moved correctly. What's that? Creates an iterator. So when you collect into this, these slices borrow from tags. Okay. You move text into the function. What? No. Pretty hold the reference to text. You move item into the closure. Yes, you did. Closure requires static lifetime. Item borrows from text, which is a local to the function scope. Even though text isn't drop until the end of the function, the compiler sees item as a borrow. You must convert item to an owned string before moving it into the closure. This item has to be owned string before moving it to the closure. Owned string. So what do I do? Item dot clone. Okay, I get it now because the text is being collected, so it holds the reference, the splitted string, right? Because it's the vector of the slices. You need to map the vector to string first. Map it. Okay, the optimized version. Let's not see that. Let's look out the issues over there. The code generally comprises an item. However, creates an iterator of them. We collect into the version. These slices borrow from text. Remove text into the function. Spread string holds the reference to text. Splitted string holds references to text. You move item into the closure. Yeah, batch work. I understand. So basically, it will either look for chunks, assuming this inside a simple block where self dot store is arc mutex. Yeah. Sequential approach. Lock once. Hmm. Lock especially before formatting. Which really require parallelism for messy text. You must batch. Yes, I know. Either you can create a chunks and do on that. Yeah, see chunk size. That's what I already told that earlier already. So you create the chunks, and it's good if you just use available parallelism method from the thread crate. That will help to clone outlook in the programs. And chunks of words to the thread. Example, 4 threads. So it created a chunks, and instead of like creating a thread for each of the word in a sentence, it created a thread for a chunk. I mean, that's what we discussed earlier. So I'm not surprised in this. It's okay. But the issue over here is how did it handle this thing? Uh, wow. Okay, so I think this solves it. So instead of like holding the references, it need to dot map to it, and once I do the map, it will just do s dot to string, and then collect it. And instead of this, I think it will just do the own thing, right? Yes. And how did it handle panic, panic, panic? Nothing. No panic. Fred panicked. Okay, it uses unwrap or else e into error. Now I will simply use panic. So probably we can just have this thing. Can we do that? Yes. Yes. Voila. Good. So few things that we already discussed earlier. That if you remember, we said that the efficient way would be to create the chunks of the large file. So because we are using a sentence only, so you will not see any significant performance gain using threads onto this simple sentence. A simple loop that we did like earlier without wrapping it into the thread would work fine. In order to see the significant changes of the threading, we need to have a large file, and that large file has to be distributed in between the chunks. And how you calculate the chunk size? You just calculate the read the entire string or entire file using fs operations, and then you take the length of that thing and just divide it divide based on the number of available parallelism, available thread of the operating system. And how do you get those threads? We use available parallelism method, right? So this guy doesn't tell us about how do you really get the threads out of it, but I'm telling you, we'll use thread dot, that method available parallelism that we already saw on the very start of this stream. Based on that thing, we will calculate, kind of distribute the chunks of that file onto each of the thread, and then we loop on the chunks length. Let's say the file size is, let's say, 12. Okay, and the available parallelism method, we got 3 threads. So how do you calculate the how much chunk will each thread get? You'll simply just divide it, right? 12 by 3. So each of the thread gets 4 chunks, right? So you spawn a single thread for 4 chunks. So that's the logic here. In case we have a very large file, right? This way that will be efficient because each thread will now work on a specific chunk. But here it's inefficient. Why? It's inefficient because we are running, we are kind of creating a thread for each of the word in the string, right? If you look at the splitted string, if you see, okay, no, if you see this thing, let me just show you this word 1 2 3 4 5 6 7 8. So we have 8 words in this sentence, so basically 8 threads will spawn. So it's inefficient. Also it is somehow, I don't think it will alter because each thread will only work on that. So basically it will have a lock, and but overall it's inefficient. Why? Because I'm just spawning for each word. But that's what I already told earlier. So yeah, so this is a pretty common format that we use to work around with when we generate multiple thread, right? What we do, we wrap things that we need to pass on to multiple threads in arc and mutex. Arc just increment the count of, it helps us to share the ownership between the multiple threads, and mutex help us to prevent the data races between those threads, right? By giving a feature called method called lock, so that each thread acquires a lock, and once a thread acquires a lock, no other thread can directly mutate that thing, that specific thing on which the mutex lock is acquired. Okay, now let's run this thing. Hopefully this will be a little bit heavy than the default approach. Let's see. That is good, right? I have the mutex over here that says dog one, brown one, quick one, the one, right? Now instead of just sending back the mutex guard that I'm getting, self.store is a mutex guard, right? So what I can get over here is, I can say lock like that, and I can have, yeah, that is good, right? Mm, see, I have this thing now, so it is good, right? It's working, but it's still heavy, right? Because 8 threads are working on it, so basically it doesn't do anything. But you get the idea, right? How to deal with the things where we have to generate multiple threads, and how do we share the data in between the threads. So we have to basically wrap it on arc and mutex. So yeah, so this exercise is done, right? We need to use arc and mutex around those. The only thing that it needs to be done is to read a file. So instead of directly sending the string, you can create another function over here that reads a file using fs operations. And yeah, that's it. Pass that string over here, and then here you can just create the chunk size. We'll use available parallelism method to get the number of available threads, and then we give a specific chunk size to each thread, and instead of running a loop over here, we'll run a loop on the total chunk size that we have, right? That's simple. So yeah, this is the idea. This is the common pattern to work around with threads, right? So you see the pain over here, right? We need to use mutex, lock and everything, right? And just to make it asynchronous so that it doesn't block, right? So that we can have the parallelism. Now this question, this exercise over here that we did is basically to tell us about how async environment going to help us in these situations, right? So that is why it says that do this before touching Tokyo. Tokyo is an async runtime, right? So that async's corporative model feel like a relief rather than an arbitrary library. So the goal of this exercise is to let us know the benefits or the importance of an async runtime. Okay, so that now by solving this exercise you understand why async runtime is necessary, how it helps, how it reduces the number of lines of code, and what it does under the hood, right? So that instead you think that okay, it's another library, just use it. You now know that okay, why we actually need it by working around with threads. So yeah, I think we have it enough. So we are going to drop the stream now. Thank you everyone for joining. I'll see you on the next one. Bye bye. Bye bye. Yes.